before we can add these two fractions together, we're going to need a common denominator. And before we can find that least common denominator, we're going to have to factor our denominators. So let's begin with that. The only part that can be factored is the second one. I guess you could argue the first one's already been factored. It's 9 times x squared. However, we can do a greatest common factor on our second fraction. Both of those terms have a 3x in common, so I'm going to take out a 3x. And what's left over then is going to be x plus 1. If you can't factor, you can't do any of these problems, so you may want to go back and watch some of my factoring videos if you need help with that. So it's been factored. Let's go ahead and build our least common denominator. Start with your coefficients. There's a 3 and a 9. The smallest multiple that 3 and 9 have in common is 9. So I'm going to need a 9 as part of my least common denominator. And then I'm going to need to take every variable piece that I see and the highest power of that variable. So there's an x squared and an x. I'll need the higher of those, so I don't need all of them, the higher of them. So I'm going to need x squared. I'll need that piece. We've called this sort of building the perfect bicycle if you've been watching the other videos. The other piece that I'm going to need, I see this variable chunk, I call it, that x plus 1. So I'll need that piece as well. So those are the three pieces, the 9, the x squared, and the x plus 1, that I'll need all my denominators to become if I want to be able to add these together. So let's go ahead and take a look at what I have in each denominator and then see what's missing to turn it into this LCD. So the first fraction, it has the 9. Some people like to do a checklist. So I've got the 9 piece. I've got the x squared piece. I can check that off. But I don't have that x plus 1. So the first fraction will need to be multiplied by x plus 1, not just in the bottom, but in the top as well. Because really, multiplying something like x plus 1 over x plus 1, that's really just a 1. And multiplying by 1 doesn't change anything. Notice I've used parentheses to remember to distribute when I multiply this by 7 in a moment. Okay? Let's take a look at the second fraction. Let's use purple, I suppose. The second fraction, it has a 3 in front, but it needs a 9. Now, some people think, well, it's missing a 9, so multiply by 9. But that's not what I want to do. I want to turn this 3 into a 9. So think, what do I need to multiply 3 by to make 9? And that's, of course, 3. So I'll multiply the top and bottom by 3. However, I also want to get x squared, and right now I just have an x. So I'll also need to multiply by x. Now I have the x plus 1 piece. I forgot to check that off. I have that piece, so I don't need to multiply by the x plus 1. So I'm multiplying by 3x to turn this into a 9x squared. Okay? So let's go ahead now and get our final answer at least started. So I'm going to go ahead and make one big fraction line. And I know my denominator is going to be this LCD that we just found. So my denominator is 9x squared and then x plus 1. I'll need to multiply my numerators together. Notice I didn't do any multiplication with the denominators. Leave the denominator the way it is. So the first part, the part I did in orange, I have to do x plus 1 times 7. Well, distributing gets me 7x plus 7 for that piece right there. And then the second part that I did in purple, I've got to multiply x times 3x. That gets me a 3x squared. So there's everything now added together as one single fraction. The only thing I can do, well, there's not even any like terms I can combine. I guess the only thing I could do is I could write it in descending order, I suppose. So I'll do that. 3x squared plus 7x plus 7. And then don't forget to include your denominator again. I guess I didn't really need to do this step at all. 9x squared, and then times x plus 1. The only thing I should try to do is refactor that numerator. Every now and then you're able to refactor and then cancel something out. If you can do that, you have to. So it's worth checking for. In this case, the numerator doesn't factor, but we should try to factor it if we can. I think in our next video we actually can do some canceling, so you may want to watch that one if you want to see what would happen.